Okay, in part 4, let's see if we can put all of this together so I can show you how to use the skew-T diagram to see if a cloud will form. Okay, this red line that you see here is the environmental temperature. That's the temperature measured by the weather balloon that's launched into the atmosphere. So if I ask you to give me the temperature of the atmosphere, the temperature of the environment at 850 millibars, you would start at 850 and go over to the red line, which is the isotherm, the temperature line of the environment, and pick off the value at 850. It looks like it's about 1 degree Celsius. And how do I know that? Again, I want to follow the isotherms, and since 1 degree is not on top of the isotherm, I go down parallel to the nearest isotherm, and I see if I go down to the x-axis, I come to about 1 degree Celsius. Now, what would the temperature be at 1,000 millibars of the environment? So I go to 1,000, I scroll over, and I see the red line intersects the 1,000 millibar line about right here. I do not go straight down, but I go parallel to the nearest isotherm, and I see that's about 11 or 12 degrees. So the atmosphere goes from 12 degrees at 1,000 millibars up to about 1 degree Celsius at the 850 millibar level. Now, what about the temperature at 300 millibars? Well, I go to 300 millibars, go to the red line. Again, do not go straight down because these temperatures are skewed from lower left to upper right. So I find the nearest isotherm, which is this one, and I follow parallel to it until I reach the value on the x-axis. And that value is right around minus 45 or 42. If I were to ask for the dew point temperature at let's say 850 millibars, can you tell me what that is? Well, the dew point temperature is represented by this blue line. So this is the dew point temperature measured by the weather balloon as it goes up through the atmosphere. So I go to the 850 millibar level and intersect it on the blue line. And again, since we're looking at temperature dew point, I'm going to go down parallel to the nearest isotherm, and I see it's about minus 1 at 850 millibars. I'm just looking down here because this is where my temperature value is, or in this case, dew point. Now you'll notice the temperature and the dew point are pretty close together. In fact, there's about a 1 degree difference or a 2 degree difference between the temperature at 850 and the dew point at 850. Since the temperature and dew point are very close together, that would be a moist atmosphere at 850 millibars. You recall the dew point depression is the temperature minus the dew point temperature, and if that value is less than 5, we would consider that a moist value. So now you know how to read temperature. Now, environmental temperature, we're not talking about air parcel, we're talking about environmental air temperature and environmental dew point temperature. Now in the next module, I believe part 5, we'll talk about how to compare the air parcel temperature with the environmental temperature. If the air parcel is warmer than the environmental temperature, the air parcel will continue to rise. If it continues to rise, the air parcel will cool. And if the air parcel cools, it will eventually reach the saturation vapor pressure line, just like in mountain sim. When it reaches that line, then condensation occurs.